the other main type of sequence, other than the arithmetic sequences, are the geometric sequences. And these two are often called GPs, short for geometric progressions, a name they used to be known by. So the terms of a geometric sequence can be generated from the first term, we've already seen that we call that A, by repeated multiplication, by a common ratio, and we call that common ratio R. Now remember that with the arithmetic sequences, it was constant repeated addition with D, whereas here we're multiplying again and again by R. So what that means is to find any one term, if you know the term before it, you can just multiply by that common ratio R, and we've seen why n has to be greater than or equal to 2. So for example, 2, 6, 18, 54, 162. A bit of inspection here, you can see that we're multiplying by 3 each time, so that common ratio must be 3. Here, 20, 10, 5, 2 1/2, 1 1/4. Here they're halving every time. So what if we multiplied 20 by to get 10? Well, we've multiplied it by half. Don't think of it as dividing by 2, think of it as multiplying by half. So R is equal to a half. Note that when R is less than 1, we're going to have the terms getting smaller as we go. So that's something to think about and to notice. So then the official test for a geometric progression is that any one term, if you divide it by the term that came before it, must give you that common R. And we can check that. 6 divided by 2 gives us R. 18 divided by 6 gives us R. So in practice, when we come to check for it, we need to find at least 2 jumps between successive terms to confirm that R is the same each time, at least 2. So here we could say the third term divided by the second term would need to be equal to the second term divided by the first. So for one like this, 2, 6, 18, we would prove that by saying, well, the left-hand side is 18 over 6, that's 3. The right-hand side is 6 over 2, and that's also 3. So if R is 3 both times, then we've got a geometric sequence. So then how do we come up with a formula for the nth term when we're working with a geometric sequence? Well, we still call the first term A, but every time we generate a term, we get it by multiplying by that common ratio R. So it makes sense that the second term is going to be A times R, and the third term is going to be this one, AR times R again. Now what do you get if you have AR times R? Well, you have AR squared. And the next term, we'll need to take this term and multiply it by another R, so it won't be R squared, we'll have R cubed. And again, we've got a pattern here. We seem to always have the A, and then we've got R to the power of something, and that something is always a number that's 1 less than this. So what's the number that's 1 less than n? N minus 1. And this is then our formula for the nth term of a geometric sequence, where of course A is the first term and R is the common ratio. A couple of tips when you're working with GPs, something that's different from APs is that no term can be 0, because then your common ratio is actually undefined. Now you might think, well, it's okay to have 0 on the top of a fraction. What if it's just the nth term that's 0? Well, what would come before that? And of course, if the first term is 0, then your very definition of the nth term would mean that all of the terms would be 0, because they'd all be multiplying by that 0. You wouldn't have a progression, you wouldn't have anything in fact. Now, if the signs alternate, you'll see that R is negative. So I've got an example of that here. To get from 10 to minus 100, I've multiplied by minus 10, multiplied by minus 10, multiplied by minus 10. So here R is negative 10, and you'll spot that pattern of the signs alternating.